Hi everyone, today we are talking about writing linear functions from a word problem. As a reminder, you do not need to write down everything that we'll cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember that you can pause the video to jot down important notes, rewind to view information again, and fast forward if you think you got it. Just be careful, make sure you don't fast forward too much that you end up missing out on something important. Let's begin then with a review. We will be asked to write a linear equation after reading a word problem. So in order to write a linear equation or function, we are going to go to our y equals mx plus b, our slope-intercept form. So that means we need to understand slope-intercept form. So as a reminder, y equals mx plus b gives us two pieces of information. That's our slope, which is the m, which stands for move, and our b, y-intercept, which stands for the beginning or starting point. So whenever the word problem talks about any kind of change or moving, that's going to indicate to you that they're talking about the slope, or the m. So you can use rise over run or the slope formula. The y-intercept will be talked about if the problem talks about the starting point or the beginning. So that's going to be at the end of your equation. And on a graph, it is the 0 y value point. So this is very important as you write down your linear function answers. Make sure you have this written down before we move on. All right, on to some examples then. In this example, it tells us that the pressure at sea level is 1 atmosphere. So here, atmosphere is being used to measure. Be like 1 centimeter, 1 inch, something like that. So the measurement is called an atmosphere. The pressure at sea level is 1 atmosphere. And it increases at a constant rate as depth increases. When Sydney dives to a depth of 23 meters, the pressure around her is 3.3 atmospheres. The pressure P in atmospheres is a function of x, the depth in meters. Write the function's formula. P equals blank. Go ahead and pause the video and try it on your own first. Okay, I don't know about you, but there's a lot of words going on, and it's very confusing. They did give us one huge hint, though, that we have P as one of our variables, and we have x as our other one. And the huge hint is where they set up our equation already, P equals. Normally, it would be y equals mx plus b. So here is P. So on a table, instead of x and y, it would be x and p. And they tell us that x is the depth in meters. So I'm going to jot all this information down so I can start to make sense of things. The P is the pressure in atmospheres. I'm going to write ATM, atmospheres. So now this kind of gives me a starting point. I know my X and my P are working together. X stands for depth in meters, P stands for pressure in atmospheres. So if I ever read anything about meters or depth, I know that's going to be an X. If I read anything about pressure or atmospheres, I know that's going to be put under P. And I'm going to make myself a table so I can see if anything matches up to end up giving me a point. So the pressure at sea level is 1 atmosphere. And it increases at a constant rate as depth increases. So sea level is 1 atmosphere. So if you want to think about sea level, let's say this is someone's house, sea level is where the beach is going to begin. So that's at the ground level, okay? So the pressure at sea level is 1. How deep is the sea at sea level? Well, the ocean hasn't started yet, so the depth will be 0. It's the starting point. It'd be like if you were standing at the beach, you're standing at sea level. Your depth is 0 right now. You haven't gone down below. So at the ground level, at sea level, it's 0. So I have my first piece of information already. That kind of looks like my y-intercept, because y-intercept is always 0 for the x value and a number, which is my y-intercept. That's my starting point on the y-axis. So it looks like B might be 1. Let's keep reading. When Sydney dives, so it's going down, to a depth of 23 meters, 23 meters is how deep it will be, the pressure around her is 3.3 atmospheres, okay? So it looks like these are positives because it's telling us how deep it's going down. Looks like they're going with positives. So they're not talking about on a number line, but they're talking about just the depth. So it looks like we have 2 points. And then we already found our y-intercept. We could use these to figure out our slope using our slope formula though. So slope is y2 minus y1 over x2 minus x1. So that's 3.3, subtracting 1, y2 minus y1, and then 23 minus 0, x2 minus x1. 3.3 minus 1 is 2.3. 23 minus 0 is 23. 2.3 divided by 23 looks like it's going to come out really nicely. It's just 0.1. So instead of m, we have 0.1. Remember, they are using x, so we can keep that x there. So it looks like it's going to have a slope of 0.1x, and it's going to be plus 1. So starting point is at 1 atmosphere, and then it's going to change 0.1 atmospheres for every meter that she's going to dive. So her atmospheres are going to change by 0.1 each time. Okay, so you're looking for keywords in your word problem to help you figure out which is your y-intercept and which is your slope. As a hint, use a table to keep track of things. Let's try another problem. In this problem, the temperature of a chemical solution is originally 21 degrees Celsius. A chemist heats the solution at a constant rate, and the temperature of the solution is 75 degrees Celsius after 12 minutes of heating. The temperature T of the solution in degrees Celsius is a function of x. The heating time in minutes. Write the function's formula. T equals blank. Go ahead and pause the video and try it on your own first. Okay, so again, they're giving us a big clue. Y is the same as T, and it looks like they kept x, okay? So in my table that I'm gonna set up as I read this information again, I'm gonna have x and T. So let's see, the temperature T of the solution in degrees Celsius, so T is the temperature in degrees Celsius, is a function of, so it's going to depend on x, the heating time in minutes. So this is heating time, which will be measured in minutes. Okay, so I set up my two variables, and now I'm going to reread the problem. The temperature of a chemical solution is originally 21 degrees Celsius. Temperature in degrees Celsius. It says originally, so that kind of tells me that it's the starting point. That's my y-intercept, because it says originally. They might as well have said begins at 21 degrees Celsius. Then they said a chemist heats the solution at a constant rate. Constant rate means that there's going to be some change going on, and it's going to be the same change over time. It's going to be a rise and a run, a rise and a run, constant rate. And the temperature of the solution is 75 degrees Celsius. Remember, the T is temperature, 75 degrees Celsius after 12 minutes of heating. 12 minutes of heating. Heating time in minutes is X. So I end up with 0.21 and 12.75. And keep in mind you want to keep it as X and Y. X and Y. If you switch it up, then you're going to get the wrong answers. So we have our y-intercept, which is 21. It looks like we need to find our slope by using the formula. So slope is y2 minus y1 over x2 minus x1. So that's 75 minus 21 over 12 minus 0. 75 minus 21 is 54, and 12 minus 0 is 12. 54, yes. So now we're going to divide 54 by 12, and we're going to get 4.5, 4.5. So in our equation, we will end up with 4.5 for the slope. 4.5 times x, and our y-intercept was that 21 because it starts off 21 degrees. And there we go. Okay, so the problem will tell you what the beginning and the change is. Let's try one last problem. In this problem, it says Dominic uses 20 grams of filling for each dumpling he makes. He has 1,500 grams of dumpling filling. The grams F of filling remaining is a function of D, the number of dumplings Dominic makes. Find the function's formula. F equals blank. Go ahead and pause the video, try it on your own first. Okay, so I'm going to set it up. Y equals mx plus b. Looks like my y is the same as f. So instead of x and y, I'm going to put f over here. And it looks like d is the x. It's a function of d. It depends on d. Okay, so d is a number of dumplings. And f is the filling. And it's in grams. I don't know if that's important, but better to jot it down. All right, so let's read it again. Dominic uses 20 grams of filling for each dumpling he makes. So it looks like for one dumpling, he's going to use 20 grams of filling. And he has, F is the filling remaining. Filling remaining. That's important. Okay, filling remaining. So, okay, this one's a little different. Dominic uses 20 grams of filling for each dumpling he makes. That right there, 20 grams of filling per one dumpling. That's a rate right there because it says for each. If it's a rate, that's your slope, because your slope, remember, tells you how much you're going up and over each time. They're saying each time we make a dumpling, there's 20 extra grams of filling that we use. Up 20 over 1, up 20 over 1, up 20 over 1. So that's telling you the rate, okay? So that's your slope. And then he has 1,500 grams of dumpling filling total. So he began with 1,500 grams of dumpling filling because we want to know how much is remaining. So this one was kind of different. Previously, we had to calculate to find the slope, but here they're just giving it to you. Hey, it's going to change by 20 grams of filling each time, okay? So we have to talk about how much is remaining. So this one's a little different because we want to, our graph is basically going to be decreasing. because the amount of filling that we have is starting at 1500 and it's going to be reducing because we want to know the filling remaining. Remaining is going to get less and less and less. So the best way to describe it would be to reverse these. I would write it as y equals b minus mx. So I'm going to think about it as I have 1500 grams of filling to start out with. I'm going to write my starting point first. Normally I write it at the end. And each time I make a dumpling, I'm going to use up, that's why I subtract, 20 grams of filling each time. So this is what I'm going to write down as my equation. So hopefully you follow that. Normally it's reverse, but just so it makes sense in my brain, I'm going to see it as subtracting away from my beginning amount of dumpling filling. So I began with 1500, and each time I make a dumpling, I'm going to subtract 20 grams. Okay, so this is actually going in the reverse order. It's going like this. Okay, so 1500 minus 20. And now this is not x, this is d. I just wrote x there as y equals mx b form. Okay, so you have to read the problem and see exactly what's going on so you can make sense of it. So even though this was a positive 20, I should be able to understand from the problem that you're not adding filling. You're using up. Uses, that key word there, tells us that it's going to be subtracting 20 each time. I could have changed it around and written it like this instead. D plus 1500. Okay, it just makes less sense to me, but Khan Academy would have taken that as well. Okay, so let me know if you have any questions as you work on these problems. Remember to read them carefully, double check to make sure that it makes sense to you before you submit it. And I will see you in class.